Okay, in this video we're going to talk about a problem that is very common in calculus, a problem that is very important in calculus, and something that will lead us into a lot of different applications. And that problem is the equation of the tangent line. We talked earlier about the definition of the derivative. In other words, what the derivative is and how it relates to the curve. Quickly to recap, if we have a curve, this being our xy axis, and let's say we draw some sort of a curve, it doesn't really matter what it looks like. At any given point on that curve, we're going to have a point where this is going to be the x value and this is going to be the f of x value, and then we're going to have a tangent line to that curve, and the slope of that tangent line is something that's called the instantaneous rate of change. So the m of the tangent line at a given point is exactly equal to what's called the f prime of x, or the derivative of x, using that same x value. So at this particular point, whatever point it is that we are using, we actually know three values. We know the x, we know the f of x, which is the y, and we know the f prime of x, which is the slope. Recalling from elementary algebra, the equation of a line, y equals mx plus b, we can simply transcribe the y here, then transcribe our slope at that point here, and transcribe the x value here. Then solve for the b, and we're actually going to have the exact y equals mx plus b equation of this tangent line. So the best way to show this is with a couple of examples. The first example is here. Find the equation of the tangent line to the curve f of x is equal to 2x squared minus 3x plus 2 at x equals 1. I have the graph here. You don't actually need the graph, but it can serve to be quite useful. So let's have a look at what we're looking at here. So we've got an x value of 1, and remember we are looking for the y equals mx plus b equation of the tangent line. So we're going to go ahead and substitute the x in here, but we obviously need more than that. We need to give in the final equation the m and the b. So we need to find a way to find both the m and the b. Well, we already know that the slope of that tangent line at this point is going to be equal to the f prime of 1. And we know that the x is going to be 1, and we also know that the y is going to be the f of 1, because that's how we find the y value. So then we should find a y value. Well, the y value graphically is 1. If you wish to use the function, because most of the time you won't have the graph, all we have to do is substitute in the 1 here. Find the f of 1, which is 2 times 1 squared minus 3 times 1 plus 2, which is 2 minus 3 plus 2, and that is 1. So we know that the f of 1 is 1, which means that when the x value is 1, the y value is also 1. So then we can go ahead and substitute in the 1 here. And what we have here is 1 equals m. X happens to also be 1 in this case, plus the b. So as of right now, we still don't really know anything about the m or the b, because what we have is 1 is m plus b. It doesn't really help us a heck of a lot. So what we need to do is find the slope of the line tangent to the curve here. It's going to look something like this. That line appears to be somewhat generally tangent to the curve, and we know that the slope of this from the previous page is equivalent to the f prime of x, because the f prime of x will identify, based on the properties of the derivative, what the slope is of any line tangent to a curve at a given point. So what we should do here is take the derivative of our f of x function using the power rule. So if our f of x function is 2x squared minus 3x plus 2, we'll use the power rule, bring down the power 2, and we're going to end up with 4x by reducing the power, and it'll be minus 3 because this is a power of 1. Okay, so then what we're going to do is we know that this is the equation of the derivative, which for any x value of this function will identify the slope of the line tangent to the curve at that point. So what we can do here is substitute in 1, because that's the x value that we have, and get f prime of 1 is equal to 4 times 1 minus 3, so it'll be 4 minus 3, or 1. So again, oddly enough, our m is also going to be 1 in this case. So we go back to our previous equation, 1 is equal to m plus b, and we substitute in the and we solve for b, that's 0. So remembering that our m is 1 and our b is 0, it looks like we got y is equal to 1 times x plus 0, or just y equals x. So the equation of the line tangent to the curve at that point is y equals x. Again, to recap, we found the y value by taking the x value that we know, substituting it into here, and finding the y. That's over here. And then we took the derivative of the function, and we found the slope of the line tangent to the curve at 1. That in this case also happened to be 1. And we substituted it into y equals mx plus b. You could actually do this all in one step if you'd like, after finding those numbers. You could say, well, I know that the x is 1, and the m is 1, and the y is 1, and certainly our b would still be 0. You could also use the equation y minus y0 equals m times x minus x0. It's an old equation called the point-slope form of a function, and we could actually just sub in the y0. The y0 would be our f of x at 1, so our f of 1. So y minus 1 equals, well, 1, that's our slope from over here, times x minus x0, this is the given x, so that's also our 1. And what we get by distributing here is we end up with y minus 1 equals x minus 1, add 1s to both sides, and we get y equals x. Now let's check this graphically. You'll see that when we sketch this line, it does almost appear to be the line y equals x in some capacity. But obviously this is a sketch, so what I went ahead and did is graphed both of those equations on the same set of axes. We can very clearly see that at this point this graph does appear to be tangent. Okay, we're going to go through one more example, and that's over here. This is find the equation of the tangent line to the curve f of x equals the square root of x at x equals 4. So the first thing we're going to do is identify this point, which on the graph is over here. And I'm just going to again sketch somewhat of a line here. It kind of looks like what we're trying to do here. And that looks like it might be a tangent line, yeah? And again, we need the y value, which is going to be the f of x. The x value, which is given to us, that's 4, and then we're going to fill in that 4 here. So y then consequently is f of 4 for this problem. And then we need the m, which is going to be the f prime of 4. Again, 4 because we are looking for it at this specific point. Obviously, if I drew a slope over here, it would look different. So let us, we know the x value. We know we're going to need y equals mx plus b. So what we're going to go ahead and do is find the y value by filling in the 4. So then f of 4 is equal to the square root of 4. Well, that is 2. So now our x is 4, and our f of x at that point is 2. So we can go ahead and substitute that 2 into here, and substitute our x value. We still don't know the m. We'll substitute our x value. That x value is 4, and then of course plus b. And we're not going to be able to find the b until we find the m. So to find the m, we're going to go ahead and do the f prime of 4. So we have the f of x is the square root of x, which I'm going to go ahead and rewrite as f of x is equal to x to the 1/2, just to make it easier to derive. I'll make that look a little bit cleaner. So x to the 1/2 here, so we're going to again use the power rule of the derivative to bring down the 1/2. It's going to be 1/2 x, and then we're going to subtract 1 from the power, and it's going to be negative 1/2. So it's 1/2 x to the negative 1/2, which we can rewrite as 1 over 2x to the positive 1/2, which we can further rewrite to f prime of x is equivalent to 1 over 2 rad x. So we obviously want the slope of the tangent line at 4, which is going to be 1 over 2 times 2, which is 1/4. So this represents our slope of the tangent line at x equals 4. So then we can go ahead and fill this value into here. I'm just going to copy this over here for simplicity's sake. We've got 2 equals 4m plus b. 2 equals 4 times 1/4 plus b. And 4 times 1/4 is 1. 2 equals 1 plus b, then b is 1. We already know that the m here is 1/4. So our final linear equation using the slope and y-intercept is y is equal to 1/4 x plus 1. The 1/4, of course, being the slope, and then this b over here being the y-intercept. And again, if we kind of look at this line, this is a little bit tougher to see. It does kind of look like we're going down 1 here and over something in the realm of 4. It kind of looks like the y-intercept should be over here. I don't really know visually because it could be quite close, but we can definitely see that using the equation. And again, you're certainly free to use y minus y0, which would be the f of 4 is equivalent to mx minus x is 0. It's the same thing, it's just a different way to write this equation. So here we'd have y minus y0, which would be the 2 from over here, because that represents the exact point that we're dealing with, is equivalent to m. You'd still need to go through this entire process here and transfer that over here, so that'll be 1/4. And then it'll be x minus the specific x that we are currently using, which is 4. So here again I could distribute y minus 2. It's going to be 1/4 x minus 1/4 times 4, which is 1. I add the 2 over to both sides, and we've got y is equal to 1/4 x plus 1, which of course is exactly the same thing we have here. So let's just, again, went ahead and graphed both of these functions. And we can clearly see that at one point or another here, that appears to be 4, we have a tangent. Okay, now we see that it's pretty clearly not a secant. It does not appear to cross twice. It looks like it touches the graph right at that point, which is exactly what we're going for. Certainly the y-intercept is 1, and certainly we are going up 1 to the right 4. Delta y is 1, delta x is 4. M then is delta y over delta x, which is positive 1/4. And that will solve our equation here. And the b is 1, leading us back to that same inevitable conclusion that y is equal to 1/4 x plus 1 is the tangent line to the curve at x equals 4.